Hi, my name is Quigley, based in Loughborough University. As Simon said, final year PhD student, just finishing up, doing some simulations, writing my thesis. The aim of my research was to investigate how the design of steel modular construction, which is currently used in student halls, could be used, improved to provide low energy homes that are both comfortable and affordable. So the way I approached the project was, I thought it was vitally important to understand how these buildings currently perform, to understand how they could be improved for the future. So I took two case study buildings, which were student halls of residences, one in Loughborough and one in London. I had various methods to collect the data, including questionnaires for the occupants, blower door tests, infrared thermography, temperature sensors on the radiators to infer heating patterns where the radiators were wet heating systems. I also used wireless sensor networks to measure window opening, internal air temperature, and electricity use. So that was lights, appliances, and electrical heating when there was electrical heating. So today I'm just going to discuss with you some of the data for the wireless sensor networks. This data is mostly about the Loughborough case study. And so I'm going to talk to you about electricity use in student halls. I can only really give you a really small snapshot of what I found out, so if you want to know any more, I can speak to you afterwards. I found large variations in the electricity used in the student hall in Loughborough. This is electrical heating, by the way. Some bedrooms used 4 times the amount of electricity that other bedrooms did during the 4-month period. And when you look at flats at the flat level as well, you see a big variation between the total energy consumed in the flats. Flat 2, for example, used 21% more electricity than flat 1. However, flat 2 has 5 bedrooms and flat 1 has 6, so actually it's more significant. I also found that the open plan kitchen living room areas used about 2/3 of the electricity for the whole flat, not including the corridors. So this is quite significant. Most of the electricity is used in the kitchens and not really in the bedrooms. And when we look at why there's such big differences between different rooms, why some bedrooms use 4 times the electricity that other bedrooms use, what I found was it comes down to behaviour. One person's behaviour really doesn't compare to another person's behaviour, quite varied really. But what I did find, looking through the data, is that individuals have habits, habitual behaviour related to the way they operate their building, their rooms, the way they use electricity, whether they open the windows or not. And this is an example here that shows 2 days for 2 bedrooms, same days. As you can see, it's quite different graphs here, the data is quite different. But these are 2 typical days for these students here. Room 104, you can see quite low electrical loads, less than 100 watts normally, and quite intermittent in use. During these 2 days, they have the window open as well, so the resulting internal temperature is quite low. It's actually below 20 degrees. Now you compare this to room 101, this person tended to use a lot more electricity, typically 200 to 250 watts for large periods of the day. They also use the heating a lot. In this 2-day period, they've used the heating 5 times. That's what these larger spikes are. They also tended to have the windows shut more often. So what you see is their internal temperature is typically about 5 degrees warmer than room 104. And this is what this is like for the whole 4-month period. Now, to look specifically at heating, I found similar trends, big variation in the heating energy used by different people in the bedrooms. Part of this is behaviour-based, but part of it also seemed to be due to the system. I found the electrical radiators, although they're supposed to be identical, actually they had quite varying loads. Some rooms, the radiator typically used 500 watts, where in other rooms it was more like 700 watts. So when you add that up over here, there's a significant difference just from the load of the radiator. I also found we have quite restrictive radiators in these halls of residences. To turn them on, you have to press a button in the bedroom. When you press that button, the radiator comes on for 2 hours, max 2 hours. If it reaches a certain thermostat set point before that, it will turn off earlier. I don't know what that thermostat set point is. Nobody does, and nobody has a control over it. So what I find is the radiators are quite restricted. You can't really leave them on and go away for the weekend. You have to be there to press the button. So the restrictive nature of the radiators does tend to reduce the electricity used by the heating system. However, I did find various instances when the room wasn't, they weren't really providing what I would consider comfortable temperatures. And this graph here shows a time at Easter when basically most of the students had gone away, so there was no internal loads, no heating, so the internal temperature dropped quite a lot. But this student came back and the room was like 16 degrees. So they've tried, this is a 24-hour period, and they've tried 6 times to turn the radiator on, and 6 times it's failed to stay on for 2 hours. The first time, even though it's 16 degrees, it stayed on for like 10 minutes. So this isn't really how it's supposed to be working, and it certainly isn't giving a good level of comfort. So what you end up with is people tampering with the radiators. And this is what we see, the two last parts in the top graph. This is a studio flat, just 1 bedroom and 1 kitchen. Both radiators visually look like they've been tampered with, and the data confirms that they had been tampered with. With room 301, instead of 2 hours heat, somehow they've got it to give 4 hours of heat. Kitchen 3 was tampered with in a different way, just to give heat constantly. So it was on for days at times sometimes. So as you can see, there's a massive difference in the electricity used from the restrictive radiators and the tampered with radiators. So that's quite significant variation. So to conclude, well, this is just a real snippet of what I've found out. We found some useful information out about the corridor lights. Corridor 1, nobody ever turned the lights off, so in 4 months it used 730 kilowatt hours, which is actually more than 6 bedrooms added together. Similar things with base loads. The kitchens have significant base loads, and that accounts to like half of the electricity consumed. The ventilation system as well, it's permanently on. When I measured the flow rate, there basically is no flow at the minimum setting, so basically it's using between 25 and 50 watts, effectively doing nothing. You only really get a measurable flow when you turn it up, but you get a corresponding, the noise when you turn it up kind of inhibits people from doing it. People don't really turn the ventilation system up, so it's just on constantly using electricity and not really giving ventilation flow. So right now I'm using a lot of this data that I've got from the case studies, and I'm using it to help calibrate a model in energy class, which I'll be then using to investigate design options to improve the design of the buildings. So if you want to know anything more, come and speak to me during the break time. Thank you.